Welcome Algebra 2A students to our second asynchronous session. Today we're going to be talking about linear functions, specifically graphing them using slope-intercept form as well as the intercepts. Then I'm going to show you how to graph some inequalities. Alright, a linear equation is the equation of a straight line. It's easy to remember because the word linear has the word line right in it. Right, we use simple variables such as x and y, and that means the variables don't have any exponents, and they don't have any square roots or cube roots or anything else. In order for something to be linear, right, it has to have a constant rate of change. Right? The rate of change is equal to the slope of the line. All right, so the slope is defined as the change in y divided by the change in x. You see that I have it equal to what looks like a little triangle here, y, divided by a little triangle, x. Those triangles are actually the Greek letter delta, which means change in. So it's the change in y divided by the change in x. Also, you've heard it referred to as rise over run. So we're talking about how steep the line is. So here I want you to take a look at this table and decide, does this table represent a linear function? Remember, for it to be a linear function, we have to have a constant rate of change. So that means for each equal increase in x, there has to be an equal increase or decrease in y. So for example, notice that the y here from going from -4 to -1 is 3. Going from -1 to -2 is also 3. And going from 2 to 5 is also a change of 3. So in each interval here, we had a constant change of 3. Now, as long as in the x variable, that also corresponds to an equal interval or change, in this case 1, then what we have is a linear function. And we can calculate its slope as the change in the y over a certain interval divided by the change in x on that same interval. So in this case, we get the change of y between any 2 points is 3, and the change in x between any 2 points is 1. 3 divided by 1 is 3. So we would say that yes, this is a linear function. Let's take a look at another example. Determine whether the data set below could represent a linear function. I want you to take a moment and examine the change in y and the change in x to see if they are constant. I'll give you a moment to do that. Alright, so I'm going to go ahead and start evaluating what the change in the y is. So here you notice that I take a point, the 10, and I subtract a -4 and I get 14. Then you can see that going from 10 to 24 is a change of 14, and going from 24 to 38 is also a change of 14. So we have a constant change in y. As long as we have a change in x that is also constant, then we can say that this is a linear function. And in this case, we're going up by 4 every time. So we say yes, it is a linear function. The slope can be calculated again as the change in y over an interval over the change in x. So I'm going to pick the change in y between 2 points, which is 14, and then divide it by the change in y over that same interval, which is 4. And then I go ahead and reduce this fraction to 7 over 2. And yes, you could also write that as 3.5 as a decimal. So we have a linear function here. Notice that you wouldn't take this -4, this first point, and then subtract away the -24 here, and then use a different interval on the x, right? It has to be the same interval, so like 2 points in a row, right, to make sure they're the same. And it has to be the same all the way through the table. So now determine whether this data set could represent a linear function. So look at the x and the y, the change in the x and the change in the y. We can see that we're going up by the same amount each time in the x. You know, we keep going up by 3. There's a change of 3, there's a change of 3, and there's a change of 3. So this is all good. As long as the change in the y is the same, then this is going to be a function. Well, here we get a change of -3, meaning we're going down 3. I'm taking -5, and if I subtract 3, I get to -8. All right? If I take -8 and subtract 3, I do get to -11. But to get from -11 to -20, I'd have to subtract 9. Oh, wait. So in this case, we say that this is not a linear function because it has to always be the same rate of change over the intervals. So here we went up a change of -9, and the y over that same interval in the x that was only going up by 3, and all the other y's were only going down by 3, and then all of a sudden it went down by -9, so it's not a function. It has to be the same all the way across. Right, now to graph a function that is in point-slope form, we first graph the point, the y-intercept, right? Then we use the slope, to determine the next point. So you guys have probably done this before in Algebra 1. It's pretty simple. It says here, we want to graph a line that has a slope of 3/2, and it passes through the point 1, 1. All right, well, I'm going to go ahead and I'm going to plot that point, right? There it is. There's the point 1, 1. Now I'm going to go ahead and use the slope information to get to my next point. Now, as I mentioned before, right, 3/2 can be thought of as rise over run, or change in y over change in x. So a slope of 3/2 would indicate to me to get from this point to my next point, I should go up 3, 1, 2, 3, and then over 2 and plot another point. So there we're going up 3, 1, 2, 3, and to the right 2. If this was a -3/2, then I would go down 3 and to the right 2. And once we have 2 points, we connect them with a line. Any 2 points, right, define a line because there's only one line that will connect those 2 points. So in math, when we're writing the equation of a line, think about what would be necessary to define a line. It's either 2 points, like the example we have here. So if I give you any 2 points and say connect them with a line, there's only one line that you can draw that connects those 2 points. The other way that we do it is I tell you a point, and then I tell you how steep the line is, or what the slope is. And then that also defines a point. So in this case is what I did is I gave you a point, and then I told you how steep the line is, or its slope, to get another point. So let's take a moment and let's do this example. So this time we have a slope of a line with 2/5 that passes through the point -3, 2. All right, so I need to have a starting point. So whenever I do these, whenever I'm graphing either using this method or the slope intercept, I always need to plot the point first. Then I can use the slope information to get a second point, and then that's how we connect our line. So there I graph the point -3, 2, and then now I'm going to use the slope of 2/5 to get to my next point. We can see here that this means go up 2, because that's the rise on or the change in y, and then go to the right 5. And then I plot another point, and then I just connect those points with a line. All right, so now I want you to take a moment to think about graphing the lines here with a slope of -2/3 that passes through the point 0, 2. All right, well, let's take a look at the point. Let's make sure that we have the point 0, 2 on our graphs. All right, so the point 0, 2 is in fact a y-intercept. That's when the x is 0. We can see that that point exists on graph A, that point exists on graph B, and that point exists on graph C. So every single one of these graphs can have that point 0, 2. But now let's see which one has the correct slope. All right, to get from that point on the y-axis, that 0, 2, to another point, having a slope of -2/3 means that I should go down 2 and then to the right 3 to get another point. 2, 3. So when I do that, when I tried that on A, it seems like there should be a point at 3, 0. And on the graph A, there isn't a point there. Again, that point 0, 3 doesn't exist on graph B. So we conclude that the answer must be graph C, and we do see that if I go from the point 0, 2, then I use the slope to go down 2 and to the right 3, I end up with another point on the line. And so the correct choice here is answer C. There's also a few little tricks that you could use to eliminate answers really quickly. For example, graph B. If I take a look at graph B, I wouldn't even have bothered trying to see if that's the answer. I know right away just by looking at it that it can't possibly be the answer because the slope in this case is negative. It's negative 2/3. And we see that this line is going uphill from left to right. That indicates that it has a positive slope. So if you have a line that's going uphill from left to right, so to speak, like in graph B here, that's a positive slope. I know it has to be a positive number. Graphs A and C both have negative slopes, so it could have been one of those that I had to check, and we found out that it was in fact graph C. So that's the only one that has that point that we talked about. Okay, graph the line with slope negative 2 that passes through the point 0, 4. So I quickly make sure to see that the point 0, 4 is on all my answer choices. And that is in fact the y-intercept, because that's when the x value is 0. And that point exists on every graph here. So that's going to help me eliminate any answer choices. But now I'm going to go ahead and use the slope to figure out which one of these lines is in fact the answer. Now we see that graph A is going uphill from left to right. And as I just stated, any line that goes uphill from left to right, I know has a positive slope. So I don't really need to check graph A. All right. We can see that graph B does have a negative slope. So let's go ahead and use our slope information to see if we get to another point that we need to verify that this is the graph of the line. We have a slope of negative 2. Any whole number, positive or negative, so any integer, you can always put over 1, right? Because dividing by 1 doesn't change the value. So the slope of this line is negative 2 over 1. That means to get from one point to another, I need to go down 2 and to the right 1. So let's take a look at graph B. If I go down 2 and to the right 1, I should end up on the line, if this is indeed the graph of that line. And we see that we don't. So there should be a line at point 1, 2. So here you can see that on graph C, that if I go down 2 and to the right 1, I end up with another point on the line. And so there I know that the answer is C. Let's talk a little bit about x and y intercepts. All right, the x-intercept that you've been hearing me use that word in previous slides, right, is the point where the line crosses the x-axis, right, which is the horizontal axis here, the horizontal number line. All right, a point that is on the x-axis always has the form of what I wrote here is a comma 0, where a is some number, right? So some number comma 0, but the second one, the y-coordinate, is always 0, because think about any point on this line. Let's say back here at negative 5. If I put a point right there on this line, the x-coordinate is negative 5 and the y-coordinate is still 0. So any point that is on the x-axis will have a y value of 0. Similarly with the y-coordinate, the y-intercept, that's just a point that is on the y-axis, and that it will always have an x value of 0, and then the y value of some number of whatever it is. So you can see the example here. This point is at 0, 6. point on the y-axis is referred to as the y-intercept, and a point on the x-axis is referred to as the x-intercept. We can use that information to graph, because if I go ahead and take turns letting x be 0, and then I get a value for y, I would have the y-intercept. Then I could turn around and let y be 0 to find the x-intercept. And then I would have 2 points, right? I'd have 1 point on the y-axis and 1 point on the x-axis, and then I can connect those 2 points with a line. So in this case, I'm going to go ahead and do that. You see that where the y is in this top equation, I replaced it with 0. That means that I'm going to try to find the x-intercept, because the x-intercept, again, is when y is 0. So 2 times 0 is 0. Now I'm going to go ahead and use inverse operations, right, to solve for x. So I'm going to try to isolate x on the right-hand side of this equation. I need to first get rid of this minus 8. So I'm going to go ahead and add 8 to both sides of the equation, so that I have 8 is equal to negative 4x. Finally, the opposite of multiplying by negative 4 is to divide by negative 4, so that I get that x is negative 2. Now I have a point on the line of negative 2, 0. There it is right there. Now if I can just go ahead and find the y-intercept and plot it, then I can connect those 2 points with a line, and we're done. So let's go ahead and plug in the now 0 for x. So now that we get that 2y is equal to 0 minus 8, 0 minus 8 is negative 8. Then I'm going to go ahead and divide both sides by 2. And we get that we have a y-intercept of negative 4. As a point, we write 0, negative 4. Now I can connect those two with a line. How about we try to find the intercepts of the line and graph this equation. Alright, when we have an equation that's in this form right here, where we have the x's and the y's on both sides equaling some number, we call that the general form of a linear equation. You may have heard that term before in a previous math class. It makes it particularly simple to find the x and y intercepts. We're just going to do what we did before and take turns letting x be 0 and then y. So when I do that and I solve for y, I get that y is equal to 2. So now we know that the y-intercept is at 2. So I'm going to plot a point right there at 2. We'll do the same thing to find the x-intercept, except for this time we replace the y with 0. We use our inverse operations to solve the resulting equation. And we get that x is equal to 10 divided by negative 4, which I simplify to negative 5 halves. So that means I have to go to negative 5 halves on this x-axis and put a point. Now 5 divided by 2 is 2.5, so this point is right in the middle between negative 2 and negative 3. Right there, and then I can connect these 2 points with a line. Go ahead and pause the video and see if you can find the x and y intercepts of this equation. Alright, so again I'm going to find the y-intercept by letting x be 0. Solving the resulting equation gives me that y is equal to negative 3. So the point, the y-intercept is when x is 0, so it's at 0, comma, negative 3. Now I'm going to go ahead and take turns and plug in a 0 for y. When I do that, then I'm finding the x-intercept. when I solve the resulting equation. This time, I get that x is equal to 5. So the point on the line is 5 for the x, right, when the y is 0. Right, the most common form of a line is called the slope-intercept form. You get used to seeing this quite a bit in algebra. It's the equation y equals mx plus b, where m is the slope and b is the y-intercept. Why do we use the letter m to represent slope? I think it's because it was named after a famous mathematician that came up with the slope-intercept form equation of a line. A lot of people ask, why isn't it S? And that is simply because of, I think, naming it after that mathematician. There's no good other reason. Just remember the m is slope. And the b here is our y-intercept, so where it crosses the y-axis. We already talked about that the slope is the rate of change, which means rise over run. Okay, and the y-intercept is where it crosses the y-axis. So in order to get that, if we go back and look at our graphs, right? In order to get that, I have to get the y by itself, because in slope-intercept form, the y is by itself. So I'm going to go ahead and I want to push all the other terms to the other side of the equation. So I want to get rid of this minus 2x that's over here with the y by using inverse operations. So if I want to get rid of this term, this negative 2x, I'm going to do the opposite of subtracting 2x, which is to add 2x to both sides of the equation. Then we get that y is equal to 2x plus 7. In this case, then, if I asked you what the slope was, you would say 2. And if what the y-intercept was, is at 7. If I wanted the point where that y-intercept is, then you would say 0, 7. So let's go ahead and graph that. In order to graph right, I need to start with a point. All right, and the point is right here. We're looking at it, this plus 6 at the end. That tells me where to put a point on the y-axis. So you see a plus 6, I'm just going to put a point right here at positive 6 on the y-axis. Instead of negative 2, I'd put a point right there at negative 2. In this case, I'm going to go ahead and plot that point. All right, we talked about that the negative 2 is the slope and the 6 is the y-intercept. Negative 2 can be represented as a fraction as negative 2 over 1, so we got rise over run. And to graph this, I first plot the point right at 6, and then now I'm going to plot another point. So that means I'm going to have to go down 2 and to the right 1. Down 2 to the right 1, and I'll plot another point. Down 2 to the right 1 point. Since 2 points define a line, I can just connect those 2 points with a line and we're done. So let's go ahead and write this function in slope-intercept form. Right now it's in what we call the general form, and we want to change it to slope-intercept form. Alright, remember I want to try to work to get y by itself on the left side of this equation. The first thing I want to get rid of then is this 4x term. Right, so since that's a positive 4x, we can just subtract 4x from both sides. And then we have that 2y is equal to negative 4x plus 18. Could I have put this negative 4x at the end? Could I call it 18 minus 4x? Yes, we can. It's just not the form that we're used to seeing it in, right? So we go ahead and we switch the terms so that the x is first, so that we have the mx plus b kind of form. Now we're not done yet because y isn't completely by itself. It's being multiplied by 2. Right? So to undo multiplying by 2, I have to divide by 2. When I divide by 2, I divide everything by 2. Every single term needs to be divided by 2. So both the negative 4 and the 18 need to be divided by 2. And that's how I get that negative 4 divided by 2 yielded negative 2, and 18 divided by 2 is 9. So now we have an equation that is in slope-intercept form, where the slope now is negative 2, and the y-intercept is at 9. All right, so let's go ahead and match this equation with the graph below. All right, remember, we're going to start out with a point. I want to make sure this 4 is the y-intercept on all these graphs. So there should be a point on the y-axis at 4. Yep, it's on this one right there. It's on this one right there, and it's on this one right there. Okay, so that didn't eliminate any answer choices. Now we're going to use that slope, right, to know that it should be at -2. So in each case, I should go down 2 and to the right 1 to get another point. All right. So in this case, you can see that in graph A, I wouldn't even check that if I were doing it, because I can look at the picture and I know that that's a positive slope. And I can see that we have a negative slope here. So why even check it? Can't possibly be the answer. Let's take a look at B. It does have a negative slope. So let's see if it has the correct negative slope. I should go down 2 and to the right 1. There should be a point right here. And there's not. So by process of elimination, the answer must be C. And we can see that it does indeed have the correct slope. When I start at this point, 0, 4, to get to another point on the line, I can go down 2 and to the right 1. The last thing we're going to talk about is graphing inequalities. All right? Inequalities arise when expressions are not equal, but they're rather less than, greater than or equal to, less than or equal to, or even not equal to. Many real-world examples involve expressions that are not equal. Look for words like at least, at most, no more than, less than, to identify these situations in word problems. Now, for example, John must sell at least 100 muffins to break even. Or Sarah can babysit no more than 4 kids at a time. In my first example, the word at least implies that I need to sell 100 or more muffins. So that would be greater than or equal to. In my second example, Sarah can babysit no more than 4 kids at a time. No more than implies that she can babysit 4 kids or less. And that means less than or equal to. Now, graphing linear inequalities is exactly like graphing a linear equation, like the lines we were just graphing, but there's just 2 new things that you have to consider. One is, will the line be a solid line or a dashed line? And 2, where will the shading be? To decide those things, all we have to do is look at the inequality symbol itself. Your first step would be to get the inequality into slope-intercept form, and then you can simply look at the inequality symbol to decide should the line be dashed or solid and where the shading should be. Basically, if it's greater than or less than, we get a dashed line. We don't actually want to include solutions that are along that line. That's why we dash it. Greater than or equal to or less than equal to have solid lines, because we want to include solutions that lie on that line as part of our solution set. And you can see that when the symbol is greater than or equal to, I have the shading listed in this table as shaded above. And when it's less than or equal to, it is shaded below. I would go ahead and copy this table into your notes for future reference. All right, so you can pause the video and write down this table. Let's go ahead and use that to graph this line. So first we have the inequality 9x minus 3 is less than or equal to 15. All right. The first thing I want to do is get this inequality into slope-intercept form. So I want to get y all by itself. So we go ahead and we use our inverse operations just as we were just doing to go ahead and isolate the y. So the first thing I did is push this 9x term over to the other side of the inequality by subtracting it. Then I had to divide everything by -3 to get the y by itself. And I want you to pay particular attention to this. We started out with the symbol being less than or equal to. But as you recall, when you have an inequality, in your action, to get the y by itself is to multiply or divide by a negative. you must flip the direction of the inequality symbol. So this isn't a mistake down here where I flip this symbol from less than or equal to greater than or equal to. That's why it's important to get the inequality into slope-intercept form, because that way it tells you what the direction of the shading is. Okay, so we did that. We get that y is greater than or equal to 3x minus 5. So then I'm going to go ahead and I'm going to graph this just like it were an equal sign. I would go to negative 5 on the y-axis and I would put a point. Let me go ahead and click so you can see. I would go to negative 5 and put a point. Then I would use the slope of 3 to get a second point. So that means go up 3 and to the right 1, and there's a second point. Then I'm going to go ahead and connect those with a line. In this case, it's a solid line because this has the or equal with it. So I'm going to head and graph a solid line. Now I have to decide where to shade. So we see that since it's greater than, I'm shading above. And when I mean above, is what I think about is I go to the y-intercept, I look at the y point here, and when I say the shading should be above, it should be above that point. So all up here on the top is shaded above. Never think about it as graphing left or right, but always think about shading as up or down, above or below. Alright, and then finally I use the inequality to decide that the line style should be solid and that it should be shaded above. Alright, so let's go ahead and graph this inequality. Alright, so I'm going to go ahead and get the inequality in slope-intercept form. In this case, I just have to divide everything by 2. So really we don't see a 1 here in front of this x, but there's an implied 1. And then I divided it by 2 to get a slope of 1/2. And 6 divided by 2 is 3. So we see that we have a y-intercept at 3 and a positive slope of 1/2. So I'm going to start graphing this, right, just how I would any line. I'm going to go ahead and I'm going to find the y-intercept of 3 right here, and I'm going to put a point. Then I'm going to use the slope to get another point. So this implies that I should go up 1 and then to the right 2 to get to another point on this line. I'm going to go ahead and do that. I'm going to go up 1 rather, and to the right 2. So I should have a point right here. Finally, I'm going to use the inequality symbol to decide, hey, should it be a dashed line or a solid line? Well, if you go back to your table and look, you'll see that when you have less than or just greater than strict inequalities, it's a dashed line. Then this symbol does mean less. So less means below. So I'm going to go ahead and plot my dashed line. And I go to the y-intercept and I say the shading should be below this O, so down here. You don't need to do these questions. What you need to do is go on to the course announcements and go and fill out the questions that I prepared on your Google Forms marked as Asynchronous Session 2 questions.